We'll now go ahead and take a look at our graph of our secant function. We know secant is the reciprocal of cosine. So over here I have drawn a dotted line to represent our cosine. And once again, we need to do the reciprocal. So this orange line over here is really not part of our graph, but it's there just to help us see how our secant might work. So we know we got to have the reciprocal of this value, so the reciprocal of 1 is 1. Here we're at a height of a half. The reciprocal of a half is your 2. Here you're at a height of a third. The reciprocal of a third is your 3. And similarly over here, the reciprocal of a third again is your 3. So then you get this brown horseshoe going up. Here we would have a vertical asymptote because you'd be at a height of 0. The reciprocal of 0 would be 1 over 0, which is undefined. Over here, we'd have the reciprocals of our negatives, which would give us a negative. And so we get a horseshoe going down, and then it repeats again. So we have the graph of our secant function. So let's go ahead and see what our domain is. Well, our domain should be everything except what these vertical asymptotes are. Looks like it's at negative pi over 2, plus a pi to get to positive pi over 2, plus another pi to get to 3 pi over 2. So it's really, your vertical asymptotes are at pi over 2 plus any multiple of pi. So therefore, your domain has to be everything except that. Your x-intercepts, your solid brown graph never does cross the x-axis, so you don't have any. Your range, it starts at 1, goes up forever. Starts at negative 1, goes down forever. Your y-intercept is where it crosses the y-axis, which is 1. The period, the symmetry, and the even and odd all go from your original function of cosine. Period of cosine was 2 pi, so secant will be the same thing. Cosine was symmetric about the y-axis, so your reciprocal of secant has to be. And if it's symmetrical about the y-axis, it's an even function. Tangent. Tangent's what you get when you divide your sine over your cosine, or when you're looking at your graph, your unit circle, the y-coordinate over the x-coordinate. You're going to get this graph right here. You do end up having a vertical asymptote. You would have a vertical asymptote right here at pi over 2. At pi over 2, when you go y over x, it'd be 1 over 0. Can't divide by 0, so that's why there's a vertical asymptote there. Similarly, when you get to 3 pi over 2, there's a vertical asymptote because when you go the y over the x, you get a 0 on the bottom. So our vertical asymptotes are very similar to what we've seen before whenever the cosine was in the bottom. And by the way, your basic tangent graph, you're going to just have to have that memorized. So therefore, your domain is really all real numbers except those. Your range starts at 0, goes up forever, starts at 0, goes down forever. So your range is really all real numbers. Your x-intercept, where are you crossing the x-axis? Well, you're crossing at 0, pi, 2 pi, then it would be 3 pi, so basically the multiples of pi. Your y-intercept, of course, would be 0 because you're going through the origin. Your period, how far do you have to go before it repeats? Well, in between each one of these asymptotes is one complete period, and then it's repeated again over here. Well, here you go pi over 2 to the right, pi over 2 to the left, which is a total distance of pi. So your period then is pi. When we're talking about our symmetry here, it's not symmetrical about the y-axis because each side isn't the mirror image over the y-axis. But if you would take this here, rotate it about 180 degrees about the origin, you would get this down here. So it is symmetrical about the origin. When it's symmetrical about the origin, it's an odd function. So now we'll take a look at our cotangent graph. Cotangent is cosine over sine, or if you're looking in terms of a point on your unit circle, it would be the x-coordinate over the y-coordinate. Same idea either way. Here you have your x-axis, which is more or less being covered up by a vertical asymptote. That's because when you go y over x here, for your angle of 0, you would have, x over 0, x over y, you get 1 over 0. So that's why we have a vertical asymptote here. You'll also notice we have a vertical asymptote here at pi, because when you go at pi, taking your x, which is -1, over your y, which is 0, you get 0 on the bottom again. So we have our vertical asymptotes at 0, at pi, at 2 pi. For the sake of what we're looking at, for the most part, you're going to just have to have it memorized what your cotangent graph looks like. Yes, you could go ahead and divide your x by your y going all the way around the unit circle, and you would see why the points would come up like this. If you don't want to do that, just go ahead and accept it and take the graph as it is. Now, for your domain, you know, is going to be everything except your x-coordinates, or your vertical asymptotes. Your range, you're going to start here, go up forever, start here, go down forever, so it's all real numbers. Your x-intercepts, while you're crossing here at pi over 2, go pi to get to this one. At 3 pi over 2, go to pi, get the next one, 5 pi over 2. Also go backwards a pi to get to -pi over 2. So your x-intercepts are really at pi over 2 plus a multiple of pi. Your period, you're going from 0 to pi, so length of 1, and then it starts to repeat again. So your period is pi. Your y-intercept is 0, or not available because you have a vertical asymptote there. It's an odd function, so therefore it's symmetrical about the origin.